In this video, we're going to use our knowledge of all of this trigonometry to prove various identities. So if you missed any of this important information as we recapped all the info we needed, go and have a look at some of our previous videos, but for now we're going to dive straight into identities. So something worth noting is that if ever you are given a question with one of these two words, so either the question says prove or the question says show, then you need to be very careful in your approach to this question, because that makes it a form of identity. Okay, and so we can't solve this. What I often see is that students then take it as an equation and they start to find things like a common denominator and solve. Okay, this question did not say solve, it said prove. So be very careful when we are given this kind of thing. The first thing we need to do is have a look and choose the more complex side. Now that might seem counterintuitive. It's our natural default to always go for whatever is simplest, but we need to have options. So if you have a look at this first one here, we've got a very complicated looking or complex looking fraction over here, and then just a simple tan theta on this side. So if we were to do anything on the right hand side, we've only got one option, which is sine theta over cos theta, which doesn't really help us to prove what is happening there on the left hand side. So we would definitely choose the left hand side there, and then step 2 is to simplify that side on its own. So in other words, I would then start and I would write down left hand side equals, and I would write this fraction that I'm working with, and then I would solve, or simplify at least up until a point, and either I'm going to get this to equal tan theta, or I'm going to get it as simplified as possible, and then in a separate step I could solve the right hand side. Okay, so very important. In terms of these two keywords, I often tell my students just highlight. If you see the word prove, if you see the word show, highlight that, because it's a hint that you need to break up the left and right hand side. Okay, let's look at some examples and then you'll see this whole thing unfold. So here we are given show that. So that means I can't solve this left and right hand side together. I need to choose. So I've got cos 70, cos 50 on the one side, and then only cos 10 on the other side. So if I'm going to choose the side with more options, it's definitely going to be the left hand side. Okay, so then that's going to be our first step. Left hand side equals cos 70 plus cos 50 degrees. Okay, and now I need to try and think logically, how can I get something to do with 10 here? Okay, and if ever I'm given something like this, a big hint for me would be to think about those special angles. So we've got 30, 45, and 60. That's happening in the back of my mind. I'm thinking, how can I use one of these special angles or more to help me here with this 70 and this 50? And what I notice is that I can write cos of 70 as cos of 60 degrees plus 10 degrees. And cos of 50 I can write as 60 degrees minus 10 degrees. And then that becomes a compound angle that I'm dealing with. So what I want to do then is head to my formula sheet, and I'm going to work with the cos A plus B formula, because it's 60 plus 10, and then the cos A minus B formula. And in this case, A is 60 and B is 10. So let's expand that and see what we are sitting with. So if you look at the cos 60 plus 10, that has been expanded here into cos, sin with the opposite sign. Remember that? So it was plus 10. It's now a minus here in the middle. And then if you look at the 60 minus 10, that's been expanded there. Now, one of the first things I look for, I can jump straight into substituting my special angles, but I just have a look for like terms. So we've got here cos 60 cos 10 plus cos 60 cos 10, so those are like terms. And then we've got here minus sine 60 sine 10 plus sine 60 sine 10. So remember, terms are separated by pluses and minuses. So don't worry about the multiplication sign in the middle. That unites them as one term. Okay, so what we'll see is we've got 2 of these, and then this minus plus is actually going to end up cancelling out. So what are we left with? 2 cos 60 cos 10. And now we need to think about our special angles, because this cos of 60 is going to need to be traded out. So there's our special angle diagram. It's so important that you know these things very well, because as you see, they come up all the time and they're all mixed in these questions now that we're at grade 12 level. Cos is going to be x over r. So when we head over to our special angle diagram, we find the 60-degree line over there, and then we're going to take the x coordinate 1 over the r value 2. So now in the place of cos of 60, I'm going to replace with 1 over 2 times cos of 10. Okay, and essentially what this is 2 over 1 times 1 over 2. So 2 times a half just ends up being 1. So we end up with 1 cos 10 degrees, and then go and have a look back there. It does equal to the left-hand side, and so we have proven this identity. Okay, this is one we started looking at earlier, and we agreed that the left-hand side was definitely the more complex. Okay, having a look at some of the things I can tackle straight away. Tan can be written as sine over cos, and over here I see a sine double angle. So let's get those double angle formulae ready, and then we'll see where we end up. So from the formula sheets, we can get those double angle formulae. Here we're also going to end up with 2 sine theta over cos theta, that tan is changing, minus sine 2 theta. So have a look there. Sine of a double angle ends up being 2 sine of that angle cos of that angle. So this is going to be minus 2 sine theta cos theta over 2 sine squared theta. Okay, now what I propose we do is we get a common denominator there in the numerator of our fraction. Okay, so let's make both of these a cos as a denominator. So we're going to times by cos there, and what I do to the bottom, I do to the top. Okay, we're still dividing by this sign, and it's often easier to actually write it like that, but it is up to you. I just don't want anyone to forget that this whole fraction needs to divide by the denominator, so be careful there, because sometimes people forget that minuses make separate terms. Okay, so for now I'm leaving it all together so we don't make that mistake. So over cos theta here in our numerator, that's going to be the denominator of the numerator. This is what happens when you get fractions on fractions. Okay, we're going to have 2 sine theta minus 2 sine theta cos squared theta. Okay, and all of that is being divided by sine squared theta. All right, and now what I propose that we do is we have a look at that numerator, and this is purely because once you've practiced a number of these, you start to learn some tips and tricks. Okay, so generally you change your tans into sine over cos, you sub out your double angles, and then you start to look for ways to factorize. Okay, and the reason I knew to do that was because there's this minus here that kind of guides me to say, well, I've got more than one term. Let's see what we can do. So there's a sign here and a sign here, so I think we can take that out as a common factor. So let's do that. Oh, actually we can take out a 2. I see there's a common 2 there also. Okay, so we're going to take out a 2 sine theta, and we're going to be left with 1 minus cos squared theta over cos theta. And then all of that is being divided by 2 sine squared theta. Okay, now what do we know about this here? 1 minus cos squared theta. That is one of our fundamental identities. So since sine squared theta plus cos squared theta equals 1, if we were to take this over, we would end up then with 1 minus cos squared theta, which is equal to sine squared theta. So I can then substitute this out and say, well, instead of 1 minus cos squared theta, it's actually just sine squared theta. Okay, so let's put this sine squared theta over 1, and that means we can now tip and times. So we're going to have 2 sine theta times sine squared theta. You're welcome to actually multiply those together and make it sine cubed, but you don't have to do that, over cos theta, and then this is going to become multiplied by, and then we're going to multiply by the reciprocal, so 1 over 2 sine squared theta. Okay, and now this is very exciting because a 2 can cancel with a 2, and sine squared theta cancels with sine squared theta. So we are now left with, let's take this up here, sine theta over cos theta, which we know is equal to tan theta, which is the right-hand side. So once again, we have proven an identity by breaking it up, simplifying the left-hand side, and then showing that it equals the right-hand side. Right, have a look at this one. So we've got cos 2a, a double angle, minus cos a, over sine 2a, a double angle, plus sine a, is equal to cos a minus 1 over sine a. Okay, so I have to choose now which one has more options. This one, it's not entirely simple, but there isn't really anything that I can trade out here. I mean, one I know is sine squared plus cos squared, so maybe that. But let's rather go with the left-hand side because we've got these double angles that we can work with. Right, now I need to choose which double angles I want to sub out. Now the thing about cos is that there are 3 options here. Okay, I can either have this or this or this. So I need to make an informed decision. And so what I like to do is just wait. I like to see what the rest of the terms are doing, and then I like to make a decision based on that. So I'm going to leave this now as cos 2a minus cos a here in my numerator, over, and then in the denominator I've only got one option there for the sine, so I'm going to change that to 2 sine a cos a plus sine a. Okay, now that straight away, looking at this plus sign here, tells me I need to factorize. Okay, so try and get used to these little hints that the questions give us as we solve. Okay, let's leave the numerator blank for now and factorize out. So we can take out a sine a, because both terms have that. And then we'll be left with a 2 cos a plus 1. Okay, and now I am ready to choose which double angle I can sub out here. Okay, so looking at this, I've got a sine a, and then this bracket, and here in the answer I want to have a sine a. So I need something in my numerator that's hopefully going to cancel this bracket. And so if I look at my options here, I feel like this third one is probably the best bet. Right, so now that it's there, these negative signs again make me think I need to factorize. Okay, and we can factorize 3 terms. It's a trinomial. So this is not an easy question, but it is definitely one that we can do. So let's just write this in order. So 2 cos squared a minus cos a minus 1. And if you struggle to factor with causes, you can always use the K method. So you're welcome to substitute it out and then factorize it with something you're more comfortable with. Okay, over sine a times by 2 cos a plus 1. Okay, so in this instance, this is how I factorize. You can factorize any way you want, but I'll take the factors of the first term, so 2 times 1, or at least the coefficient of the first term, factors of the last term, and then I cross multiply, so 2 times 1 is 2, 1 times 1 is 1, and then I use those to help me get this minus 1 here in the middle. So I'll need to have a minus and a plus, and that actually tells me what the signs in my 2 brackets will be. So now this is beautifully factorized as 2 cos a plus 1 multiplied by cos a minus 1 over sine a times by 2 cos a plus 1. Okay, and now have a look at this. This is great news. Those brackets are identical. We can cancel them out. And so what I'm left with is a cos a minus 1 in the numerator over a sine a in the denominator, which is equal to the right hand side. So there's another identity proven. Just a quick word of warning. Remember here that if you're given double angles like this, cos 2a minus cos a, those are not like terms. So don't be tempted to say, well then cos 2a minus cos a is cos a. then you're going to be stuck. Okay, remember, the minute you see a 2, you want to get into these double angle formulae and use them to solve.